Venus's 900-degree atmosphere is made up of mostly carbon dioxide, with enormous clouds of sulfuric acid. These clouds produce orange lightning bolts up to 100 kilometers long. The air pressure on Venus' surface is about 92 times greater than Earth's sea level pressure, similar to the pressure found 3,000 feet underwater on Earth. Venus is home to an extensive and diverse range of volcanoes. It has more volcanoes than any other planet in our solar system, with over 1,600 identified so far. Venusian volcanoes vary widely in size, from small shield volcanoes to massive complexes that dwarf anything found on Earth. Scientists currently believe that Venus started out much like Earth during its early history, with seas of liquid water and much lower surface pressure. Over long periods of time, increasing volcanic activity is thought to have pumped massive amounts of carbon dioxide and sulfur dioxide into Venus's atmosphere. This caused temperatures to increase, eventually boiling off all of Venus's water. The enormous amount of water vapor, then present in Venus's atmosphere, trapped even more of the sun's heat. At this point, the surface temperatures on Venus began climbing to hundreds of degrees, and carbon dioxide, trapped in rocks, began baking out into the atmosphere. Only 6 images have ever been captured from the surface of Venus. The panorama, shown here, came from the front camera of the Soviet Union's Venera 14 probe in 1982. The Venera 14 lander was designed to withstand Venus's hellish environment for only 32 minutes, but continued to return data for 57 minutes. Venus rotates on its axis extremely slowly and in the opposite direction of most planets, taking about 243 Earth days to complete one rotation. This means that Venus's day is longer than its year, which is about 225 Earth days. Also, unlike many other planets in our solar system, Venus has no moons or natural satellites. In September 2020, scientists reported the detection of a rare and potentially biologically relevant gas called phosphine in Venus's atmosphere. On Earth, phosphine is typically associated with biological processes. The discovery of phosphine was unexpected because it is a highly reactive gas that should be destroyed by the harsh conditions in Venus's atmosphere. Some scientists propose the existence of aerial microbial life forms, known as aerobes, that have evolved to survive in the extreme and acidic environment of Venus's clouds. Scientists have proposed the idea of constructing floating habitats or cloud cities in the upper atmosphere of Venus as a potential future human settlement. The proposed cloud cities would float at altitudes of about 50 to 60 kilometers above the Venusian surface, where temperatures and pressures are similar to those on Earth. Floating habitats could be designed to move within the cloud layer to explore different regions of Venus, potentially conducting scientific research or resource mining.